A rocket streaks across the night sky, just a few seconds from impact. Air raid sirens scream, radar locks on, but this time there is no missile fired to intercept it, no explosion in the sky. Instead, an invisible beam of light flashes upward, and the rocket simply disintegrates. Not in science fiction, not in a futuristic movie, in modern Israel. For decades, missile defense has been one of the most complex challenges in warfare. Intercepting a rocket mid-air sounds simple in theory, but in reality, it requires incredibly fast detection systems, sophisticated tracking algorithms, and interceptor missiles that can cost tens of thousands of dollars each. And when thousands of rockets are launched at once, as has happened repeatedly in conflicts around Israel, the cost and logistics of stopping them become staggering. So engineers asked a radical question. What if the interceptor wasn't a missile at all, but a beam of light? That idea eventually became Iron Beam. To understand why Iron Beam matters, you have to go back to the early 2000s. Militants in Gaza began firing short-range rockets into Israeli towns. These rockets, often homemade and crude, weren't particularly accurate, but they didn't need to be. Even a single rocket landing in a city could cause casualties, panic, and disruption. Israel responded by building one of the most famous missile defense systems in the world, the Iron Dome. Iron Dome was a technological breakthrough. Using radar and battle management software, it tracks incoming rockets and calculates where they will land. If a rocket is heading toward an empty field, the system ignores it. But if it threatens a populated area, Iron Dome launches a Tamir interceptor missile to destroy it mid-air. The system works remarkably well. In many conflicts, interception rates have exceeded 85 to 90%. But success came with a hidden problem: economics. Each Tamir interceptor reportedly costs somewhere between $40,000 and $50,000. Meanwhile, the rockets fired at Israel can cost only a few $100s, or even less. This means attackers can force defenders to spend vastly more money just to maintain protection. And when thousands of rockets are launched in a short period, interceptors can also run out. Engineers needed something cheaper, faster, and effectively limitless. That's when the concept of laser defense returned to the spotlight. The basic idea behind laser weapons has existed for decades. A high-energy laser concentrates light into a powerful beam capable of heating and damaging materials. If you focus that energy on a rocket or drone long enough, the heat can burn through its structure, detonates its warhead, or cause it to break apart. But making this work in real combat conditions has been extraordinarily difficult. For years, laser systems were bulky, unreliable, and extremely sensitive to weather and atmospheric distortion. Early experiments during the Cold War required massive chemical lasers that were impractical for battlefield use. Advances in solid-state laser technology changed everything. By the 2010s, Israeli defense company Rafael Advanced Defense Systems began developing a compact, mobile, high-energy laser capable of integrating with the same radar networks used by Iron Dome. The result became known as Iron Beam. Instead of firing missiles, Iron Beam fires concentrated laser energy, estimated around 100 kilowatts or more, toward a target. The beam travels at the speed of light. There is no travel time to calculate, no intercept trajectory. Once the target is locked, the laser simply stays focused on a single point until the object overheats and fails. The moment that happens, the rocket or drone is neutralized. What makes this revolutionary is not just the technology, it's the cost. Firing a laser shot costs only the electricity required to generate the beam. Estimates suggest each engagement could cost just a few dollars. Compared to tens of thousands for a missile interceptor, the difference is enormous. But Iron Beam isn't meant to replace Iron Dome. Instead, it acts as another layer in Israel's already complex air defense network. Think of it like a defensive pyramid. At the top sits Arrow, designed to intercept long-range ballistic missiles, even outside Earth's atmosphere. Below that is David's Sling, built to stop medium-range missiles. Then comes Iron Dome, protecting against short-range rockets and artillery. Iron Beam adds something new, a laser shield designed primarily for short-range threats like small rockets, mortar shells, and increasingly, drones. And drones have become a major reason laser defense is suddenly so important. Across modern battlefields, from Ukraine to the Middle East, small drones have transformed warfare. Many are cheap, mass-produced, and capable of carrying explosives or surveillance equipment. Missile interceptors can stop them, but doing so is incredibly expensive. A laser, however, can target them repeatedly without worrying about running out of ammunition. If the power supply keeps running, the weapon keeps firing. That's the dream behind Iron Beam, near limitless defense. Still, the technology isn't perfect. Lasers have one major weakness: weather. Heavy rain, fog, dust, or smoke can scatter laser energy and reduce effectiveness. Unlike a missile interceptor, which physically collides with its target, a laser must maintain a clean path through the atmosphere. Engineers have spent years designing adaptive optics and beam control systems to compensate for these issues. But even today, lasers perform best in clear conditions. This is one reason Iron Beam works as part of a layered system rather than a standalone solution. If weather conditions reduce laser effectiveness, traditional missile interceptors can still step in. Another challenge is dwell time, the amount of time the laser must stay focused on a target to destroy it. Depending on the material and distance, it might take several seconds of continuous exposure to burn through a rocket casing or drone structure. That might sound fast, but in a massive barrage of dozens of rockets, the system must prioritize targets carefully. Despite these challenges, the progress has been remarkable. Israel first publicly demonstrated successful interceptions with laser technology in the early 2020s. By 2022, officials announced that Iron Beam had successfully shot down rockets, mortars, and drones during testing. In 2023 and beyond, Israel began accelerating deployment plans, seeing the system as essential for future conflicts where adversaries might launch overwhelming numbers of inexpensive weapons. And Israel isn't alone in pursuing laser defense. The United States, China, Russia, the United Kingdom, and several other nations are racing to develop high-energy laser weapons. The U.S. Navy has already deployed experimental ship-mounted lasers capable of disabling drones and small boats. But Iron Beam stands out because it's designed specifically for large-scale battlefield use, protecting civilian populations from constant rocket threats. And that changes the equation of modern warfare. For centuries, defense systems have relied on physical ammunition: arrows, bullets, missiles. Every shot costs money. Every interceptor is a limited resource. A laser weapon flips that logic. Instead of launching something, you simply turn on the power. In theory, a laser defense system could fire thousands of times without needing resupply. If that vision becomes reality, it could reshape air defense around the world. Imagine airports protected by laser systems that destroy hostile drones instantly. Military bases shielded from rocket attacks without the need for expensive interceptors. Warships defending themselves from swarms of drones using nothing but concentrated light. What once sounded like science fiction may soon become routine. But perhaps the most remarkable thing about Iron Beam is how quietly it represents a technological shift. For thousands of years, human warfare has been defined by projectiles, objects launched through the air. Now the battlefield is beginning to include something fundamentally different: weapons made of pure energy, invisible, silent, and moving at the speed of light. The first time a rocket disappears from the sky because of a beam no one can see, it marks more than just a successful interception. It marks the moment when warfare officially entered the age of directed energy.